This video is to go over domain and range. When doing domain and range, it's really important that you know that domain is all of the x values of a relation. And to find the domain, it will help you to ask yourself, how far left does the graph go? How far right does the graph go? And we ask those questions in that order. Range is the interval of all the y values. And when we ask the questions for range, we say, how far down does the graph go, and how far up does the graph go? So refer to those questions each time you answer domain and range. I am going to use interval notation to write domain and range. Often people also use inequality notation, but typically in pre-calculus and calculus, they use interval notation, and so I'm going to use that to teach it at the Algebra 2 Math 3 level or Math 2 level so that you're prepared for those higher level classes. So a bracket, the square bracket, like this right here, is used when a number's included. So that's like a closed dot, an actual piece of the graph, a number that could physically be graphed. And that's the same as if we had less than or equal to or greater than or equal to. Same thing. We use parentheses if a number is not included on the interval. So this would be like an open circle or infinity. Since we can't physically plot infinity, we don't know exactly the value of infinity. And so this would be the same thing as if we had a less than or a greater than sign. All right, so let's hop in. We have a linear function here. And to do domain, I ask myself how far left and how far right. So I always like to pretend that I'm just like a little stick figure on a journey. And if I was walking to the left, really I'm walking this way, but if I'm walking to the left, I would be traveling along this line and it would be going left with an arrow forever. And we call left forever on a graph negative infinity, because if you were going to travel along this number line forever, it would keep getting negative until negative infinity. So it goes left until negative infinity. And then if you were that stick person again and you were traveling to the right, you'd be following your line to the right and it would continue forever positively to the right. So we say positive infinity. You will never see a positive infinity on this side. You will never see a negative infinity on the other side. It's not possible to go negative infinity to the right, and it's not possible to go positive infinity to the left. For range, we ask ourselves the question, how far down to how far up? And so if I'm the stick figure traveling along this line and I'm thinking about down, well, the arrow not only points to the right, but it also is pointing down. And so it goes down forever, which we call negative infinity. It is going up forever. Left and up is what that arrow is doing. It's going up forever, which is positive infinity. And this is true for all linear functions except for those that have zero or undefined slope. Their domain and range varies. All right, number 2 is a parabola, a quadratic function. And number 2, it looks like it's not getting wider forever, but it actually is. It's just slowly getting wider forever. And so it's going to keep, the way you get a quadratic is to square a number. So you could take any of these numbers and square them. And so it's going to get wider and wider and wider. It just takes a really long time. It's going to keep going up. It's going to keep getting wider. And so it is negative infinity to positive infinity. And that is true for all parabolas that are right side up or upside down. For range, we ask ourselves, how far down does it go? And we use the y-axis. So if I'm looking at the y-axis, it goes down to this point. That y value is -4. And so I put a bracket because it's physically the lowest point on the graph. That's its y value, not its x value. We always use y values for range. And it is going up forever, which I call infinity. Number 3. This time we have no arrows, so we are going to have brackets or parentheses on and a number on every side of our interval. So when I ask myself how far left, all right, I'm looking at the x-axis for left. That's right here. That's the furthest left it goes. That's at 0. It is a closed circle, so I use a bracket. The right side stops here. That's at 3. It is an open circle at 3 to the right, so I have a parenthesis. All right, for range, we say down to up. At this same spot right here, I am at -4, and it is open, so I use a parenthesis. As I travel up the graph, I am at, and I have made this very messy, let me do some erasing here. As I travel up this graph, the highest point is right here. The y value there is at -1. And that is a closed circle, so I'm going to use a bracket. All right, number 4. Let's go ahead and draw some arrows on the ends of this graph. It should have them. It's continuing on. They just got cut off. The domain for this function is very unique because, as you can see, there's no graph in the middle of these two pieces. And so there's no x values that are a part of the domain in between those. And so it goes left forever because these arrows are pointing left forever. So it goes -infinity to the left. And then as we come to the right, it stops right here. And that is at -5. And there's a gap. Oops, I messed up. I should have put a bracket because it's physically part of the graph. Because I hop all the way over here and I have this large gap there, I am going to do something called a union. And this just means, hey, the domain has these x values and also these other ones. And so it starts back up at +5 with a bracket, and it's going to go right forever. So we use that union when there's two sections of the domain, when there's a gap. All right, for the range, it's pointing down forever, goes down forever. It's also pointing up forever, goes up forever. -infinity to infinity. There is no y value. There is nothing on the y-axis that you couldn't look and find part of the graph. There's always going to be a graph at any part of the y-axis. And so the range is -infinity to +infinity. All right, number 5. We have a cubic function, it appears. And it is going, we got some arrows here. We know it's going down forever. We know we're going up, but it's also going left and down. It's one of those, again, one of those skinny ones that looks like it's not going to keep getting wider, but it is. And so it's going to be -infinity to +infinity for both things. It goes left and right forever and down and up. It's getting wider and wider and wider just very slowly, but those arrows are pointing down and left and right and up. All right, we got a circle. A circle is closed intervals. We're gonna have numbers again because it does not go on forever. So my domain, I say how far left? Well, this is the farthest left point, and that's at -6. I'm gonna use a bracket because it's a physical part of the graph. It's not an open circle or an arrow pointing to infinity. And to the right, I put 6, and it's also a bracket. The range, we say how far down. We always ask down first, then up second. So down, it's going down to -6 and up to -6 on the y-axis. And so the range ends up being the same as the domain. All right, number 4 is a unique scenario. Remember to pause at any time. I'm going to work through these quickly just so this video is not super long. But number 4, the arrows are pointing left and right, so that's going to be -infinity to +infinity. But if you notice, it's a horizontal constant line. A constant line only has this one y value. It looks like it's at 5 because it's between 4 and 6, and we write it like this. It only has one. Only has one y value. There's no comma. Don't go from here to there. It's just 5. All right, number 5. My domain, I'm asking left to right. Well, this arrow, although seemingly pointing down, is also pointing left. It's getting wider on that side. So it's going to go to -infinity because we always call the left-hand side of the number line -infinity. It keeps getting more negative. As I travel to the right, though, I stop. And I stop at 2 on the x-axis. And it is an open circle, so it's going to get a parenthesis. The range is a little interesting for this one. It does go down forever, -infinity. And then we say, well, how far up does it go? Well, it doesn't stop at that open circle. It stops right here at -1 because I'm using the y-axis for the range, the x-axis for the domain. And so it goes up to 1. It's part of the graph. It's not open. I use a bracket. All right, number 6, it's going left and right forever. It is going down forever, negative infinity. We always put down and then up. Up is up to 2, and I have a bracket. All right, number 7 is going left to negative infinity. But there is an asymptote here. This is a rational graph. It's approaching this line, it's curving into it, but it's never going to touch 1. So we put a 1, we use a parenthesis because it's never actually going to touch 1. And then it hops over that line, starts back up 1 to infinity. For the range, there's a horizontal asymptote at 2. It's where you find the asymptotes by where that graph is curving and going kind of flat looking. It doesn't actually touch those spots. So it's curving into 2. It's not actually going to touch 2. So we say negative infinity to 2, union 2 to infinity. All right, number 8 is going left to 0. That's the x value there. And right to infinity, we're going to assume this dot's right here. It goes right to infinity because that arrow is pointing right forever. It goes down forever. And it goes up to negative 4 is the highest y value. They get brackets because it's a closed dot. It's part of the graph. Number 9, left to negative 2, right to 3. Range down to negative 2, up to 3 again. All in brackets because of closed dots. All right, this last section is asking you to use Desmos, but you could use any graphing calculator. Number 10 is y equals 3x. It is a linear function. It's going to go left and right forever. It's going to go down and up forever. So I will write, if my pen will work, negative infinity to positive infinity, negative infinity to positive infinity. For x squared, let me switch it out here. I'm going to have the parent graph for a quadratic equation. We've seen one like this earlier in the notes. It goes left and right forever. That U shape does get wider and wider even though it's slow. So its domain is going to be negative infinity to infinity. And then it goes down to 0. That's its lowest point. So the range goes down to 0 and up forever. And then lastly, we have the square root parent function. Parent function because no special transformations have happened to it. And I can see that it goes left to 0 and right forever. And then it goes down to 0 and up forever. Also, even though it looks like it gets skinnied out, but it doesn't, it's just growing very slowly. So they're both going to be 0 to infinity because it went left to 0 and right to infinity, and it went down to 0 and up to infinity. That's domain and range.